In 1977, humanity launched a machine into the unknown. At the time, nobody expected it to become one of the greatest journeys in history. The spacecraft was small. Its computer was weaker than a modern smartphone. Its memory could barely hold a single image by today's standards. And yet, this machine would travel farther than anything humanity had ever built. Its name was Voyager 1. Originally, Voyager was never designed to leave the solar system. NASA's goal seemed simple: visit Jupiter and Saturn. Collect scientific data. Transmit what it could. Then eventually fall silent forever. But space had prepared a rare opportunity. Astronomers discovered that Jupiter, Saturn, Uranus, and Neptune were aligning in a formation that happens only once every 175 years. This alignment allowed something extraordinary. Instead of relying entirely on fuel, a spacecraft could use the gravity of each planet like a giant cosmic slingshot, stealing tiny amounts of momentum and accelerating deeper into space. Scientists called it the Grand Tour. And Voyager arrived at exactly the right moment. Soon after launch, Voyager turned its camera back toward Earth. What it captured changed humanity's perspective forever. From millions of kilometers away, Earth appeared tiny, fragile, alone. For the first time, humanity truly saw itself from the outside. No borders. No nations. No wars. Just a small blue world drifting through endless darkness. Then Voyager reached Jupiter. And suddenly, the solar system became stranger than anyone imagined. Before Voyager, Jupiter was simply a distant striped sphere seen through telescopes. But up close, it revealed a violent world of enormous storms and unimaginable energy. Clouds larger than Earth twisted across its atmosphere. Lightning flashed deep beneath the clouds. Radiation belts surrounded the planet like invisible weapons powerful enough to damage spacecraft electronics. Jupiter was not peaceful. It was alive. But the biggest surprise was waiting around its moons. Scientists expected frozen, inactive worlds. Instead, Voyager discovered Io. A moon covered in gigantic volcanic eruptions blasting material hundreds of kilometers into space. It was the first active volcano ever discovered beyond Earth. Entire landscapes reshaped themselves beneath rivers of molten rock. Then Voyager encountered Europa. Unlike fiery Io, Europa looked quiet. Its surface was smooth and covered in long cracks stretching endlessly across frozen ice. But something was strange. There were very few impact craters. That meant the surface was constantly changing. Scientists proposed an astonishing possibility. Beneath Europa's frozen shell could exist a massive hidden ocean. An ocean warmed not by sunlight, but by gravity itself. And suddenly, one question changed everything. If liquid water exists there, could life exist too? In only a few years, Voyager transformed the outer solar system from a collection of frozen rocks into a place filled with mystery, activity, and possibility. Then came Saturn. And once again, Voyager shattered expectations. From Earth, Saturn's rings appeared smooth and elegant. But up close, they became something almost impossible. Thousands of intricate ringlets. Waves. Gaps. Structures sculpted by gravity with incredible precision. Some patterns looked so organized they almost seemed artificial. And Saturn's moon Titan revealed another mystery. Hidden beneath a thick orange atmosphere, Titan concealed its surface completely. Voyager could not see through the haze. But scientists discovered something remarkable inside its atmosphere: complex organic chemistry. On Titan, methane behaves like water on Earth. Clouds form. Rain falls. Rivers flow. Titan was frozen, yet strangely familiar. But Voyager's encounter with Titan changed the mission forever. To study Titan closely, Saturn's gravity redirected Voyager upward, away from the flat plane of the solar system. That single decision ended the planetary mission. Voyager would never visit Uranus. Never reach Neptune. Instead, it became something else entirely. A machine heading toward the edge of the solar system. Toward a destination no spacecraft had ever reached before. And nobody truly knew what waited there. After Saturn, Voyager entered a phase nobody had truly planned for. There were no more planets ahead. No dramatic flybys. No scheduled discoveries. Only distance. Year after year, Voyager traveled farther into darkness while the sun slowly faded behind it. Scientists believed they understood what would happen at the edge of the solar system. The sun's influence would gradually weaken. Solar particles would thin out. And eventually space would blend into the emptiness between stars. But reality turned out to be far stranger. In August 2012, everything changed. Voyager detected a sudden drop in the solar wind, the stream of particles flowing outward from the sun. At the same time, high-energy cosmic rays surged dramatically. These particles came from outside our solar system. From exploding stars. Supernovas. Violent events scattered across the galaxy. Voyager had crossed a boundary. The heliopause. The edge of the sun's protective bubble. For the first time in human history, a machine built by human hands entered interstellar space. And what it found was not emptiness. It found structure. Beyond the heliopause existed plasma, a thin sea of charged particles stretching between the stars. Voyager detected faint vibrations moving through this plasma. When scientists converted those vibrations into sound, they revealed something haunting, a quiet hum drifting through interstellar darkness. Space was not silent. It was alive with motion. Then Voyager discovered something even more surprising. Magnetic fields beyond the solar system appeared stronger than expected, pressing inward against the sun's protective bubble. Our solar system was not isolated. It was moving through an enormous magnetic environment shaped by the galaxy itself. And beyond that existed something even larger, the local bubble. A gigantic cavity carved by ancient supernova explosions millions of years ago. Without realizing it, humanity evolved inside a structure created by dead stars long before Earth even existed. And still Voyager continued onward. Decades passed. Its systems aged. Its power slowly faded. Engineers on Earth carefully shut down instruments one by one to keep the spacecraft alive. Every signal now takes more than 20 hours to reach Earth. Every command requires days of waiting. At one point, Voyager nearly fell silent forever. A malfunction caused the spacecraft to transmit meaningless data into space, as though it had forgotten how to communicate. But engineers refused to abandon it. Using technology from the 1970s, they rewrote software and transmitted commands across billions of kilometers into darkness. Then finally, Voyager answered. A machine launched before the internet existed spoke again from interstellar space. But Voyager carries something even more important than scientific instruments. Attached to its side is humanity's message to the universe, the Golden Record. Inside it are the sounds of Earth. Wind. Rain. Oceans. Music. Greetings spoken in dozens of languages. A time capsule for the cosmos. Long after Voyager stops transmitting, long after its systems finally die, the golden record may continue drifting through the galaxy for millions of years, carrying proof that humanity once existed. Voyager 1 did more than explore planets. It revealed that the solar system has a real boundary. That space is filled with invisible structures, pressure, particles, and magnetic forces. But perhaps its greatest lesson was something unexpected. Reaching the edge was not the end. It was only the beginning. Because beyond the boundary of our solar system lies an ocean of stars, and Voyager is still sailing into it today.